All right, let's get going then. I want to thank everyone for joining. Today, we're going to be talking about moving from mocking to service virtualization with Swaggerhub and Service V Pro. I'm Patrick Londa. I'm a marketing manager here at SmartBear, focused on our Swagger and virtualization tools. And we've got Jessica Combly on the call as well. She's a sales engineer at SmartBear, specializing on our API tools. A bit of housekeeping. If you have questions at any point during the webinar, feel free to put those into the Q&A box, and we'll try to answer them in real time if it makes sense. Otherwise, we'll try to wrap up and answer those at the end. We are recording this session, so we're going to send out a full recording of it probably either tomorrow or Monday. So you'll be able to go back and look at anything if you want to take a second look, or share it with your teams. So the session will be recorded, and we will send that out after the webinar. So as far as an agenda for today, we're going to kick off with a poll. Then we're going to talk about mocking and service virtualization, sort of why your team might consider moving from mocking to service virtualization. And then we're going to do an overview of tooling and a demo of Swaggerhub and Service V Pro and how those two interact, and the value that your team can get from that. So we want to launch a quick poll to get a sense of what folks out there are doing. So are you currently using mocking in your software development or testing? So just take a quick second to fill out that poll so we can try to tailor the webinar based off of what folks are doing. Awesome. Thank you for putting in answers for that. We're going to end the poll and share out the results. So it looks like most people on the call are using mocking, about 70%. We've got 20% who are not currently using mocking, and then 7% who are not sure. So it looks like most folks are doing mocking. We're going to cover what mocking is and why service virtualization might be the way to go. All right, so for that, I'm actually going to hand it over to Jessica. Oh, actually, real quick, we have a lot of different tools. So some folks know us for Swagger, some folks know us for SOAP UI, or some of our other tools, but just to set a baseline, SmartBear as a company, what we offer are software quality tools for development teams, testing teams, and operations teams. We're founded in 2009. We've got just under 7 million users worldwide. And we're an open source innovator. I mentioned Swagger and SOAP UI. So really trying to make it easy for teams to choose whatever software makes the most sense to improve their software quality. And what you can see here is a outline of all of our different tools across the software development lifecycle. From if you're designing, we have tools like Swaggerhub, which we'll be showing today, Collaborator for code and document review, HIP test if you're taking a behavior-driven development approach. And then in the center, you can see we have UI testing tools. A lot of people know us for Test Complete or cross-browser testing. Load Ninja, which is brand new to the family. And then our API testing tools, SOAP UI Pro, Load UI Pro, and then Service V Pro. And we'll be getting into that a little bit later on in this session. All right, so we've run the poll. We got 70% of folks who are doing mocking, and I'm going to hand it off to Jessica now.
Perfect. Thanks, Patrick. So hello, everyone. This is Jaysha. I work as a sales engineer for the API tools. So for today's session, just a quick overview. We are actually going to compare service virtualization with mocking. And then we'll go over the tooling. So we have two tools that we're going to leverage. If you're leveraging Swagger UI, which is the Swagger IO, which is the open source tooling, you can pretty much import those same Swagger specification and get started from there. I'll be actually using Swaggerhub platform. So I'll just give a quick 10-minute overview on the platform, and then we can move to actually virtualizing the services from a Swagger spec directly. Before we even get started with mocking or service virtualization, just to explain what exactly or where exactly you can apply service virtualization essentially is it's majorly used across two scenarios. So if you have a scenario where your service is not yet live, but you do have a specification built already, and you would like to get started by building unit tests across those services or functional tests, or if you have a UI team that you would like to run in parallel with your dev team so that by the time your API is actually live, you can also have your API directly, your service actually built the UI against as well so that you can have fast release to the market. So that is one of the most common scenarios that it's leveraged with. The second scenario is essentially dependencies. Now, these dependencies could be based off the service, your API that you're testing, or if you're load testing that API, in turn reaches out to like a partner API, or could be an internal API that you do not have control over. So that's like a dependency, and especially if that team is not something that you're directly managing, or if you don't have access to the dev or QA or staging environment of that API, if you end up in a scenario where that third-party API is down, and that's also gonna stop you from testing, or if that API is not reachable, or it has rate limits, or it does not have like a load testing environment, it is also gonna block your testing. So for those scenarios, you can avoid those dependencies. Or if you have something like if your API reaches out to Google Maps API and Google Maps API has rate limits or added costs associated to the usage. So if you'd like to send more than 15 requests per minute, you'll have to upgrade the tier. And essentially, it's not even a best practice to load test like a third-party API. So for those scenarios, it actually makes sense to virtualize your service, build a dummy service in your environment, and then have full control over it. So you can directly avoid the dependencies. You can have fast release to the market by leveraging service virtualization. Now, mocking and service virtualization is a little bit different. So mocking is the basic virtualization where you can create a dummy service which can give responses back for A, B, C. The depth is what makes the difference. So the current tools out there, mocking requires a lot of scripting. So if you're currently creating a dummy mock from JSON or schema-based tools, you do not have control over it. If you are having multiple team members who are actually building the services, it's very difficult to overwrite each other's changes or manage the changes that are happening. It is also pretty static. Like when I send a request, I'll get a response back, and that response would be literally the hard-coded response that I've built. Besides that, it is stateless. So if I have a scenario where I have login, search, buy, logout, and I want to maintain the state with either a session ID, since every time I pretty much get the same exact constant value coming back, or maybe a dynamic value coming back, there is no way for me to maintain the state with mocking. So this is kind of one-to-one comparison where mocking always provides like the same response, whereas virtualization can now differentiate the request based on which request came in and which specific response to dispatch and when to dispatch it. So you can also validate the request with service virtualization and then decide like which specific response you wanna. So the depth is one of the main feature that is different between mocking and virtualization, where mocking is on a single level, whereas service virtualization, you can layer it up so that you can also have scenarios where service A calls service B and then service B calls service C. So those are one of the nested API calls that you could do across. These are some of the standard like set of differences that are present across. So there is script is the main focus. It's very neatly tied to CI/CD frameworks. Mock services always have like a single response that it is dispatching. Wide number of open source tools do mocking. And so mocking is not actually bad. It's pretty applicable for scenarios where I just have two possible responses that I'm going to leverage. And those are going to be hard coded. So it makes sense to create a mock response. So this is more of an example for virtualization or service virtualization, where I have pool of responses, and based on a certain condition, for example, if I ask for what's the weather today, I will get one of the response from today. And based on the time, as well as if I have any upcoming thunderstorm or anything, that gets projected as well. So this provides you more depth in terms of managing the set of virtual responses that you have on your end. You can also have scenarios where I can cater to not just the weather, but I can also cater to like movie time answers or calendar answers. So you can have multiple services providing your response in a set of flow. So service virtualization is way more flexible. You can layer it. It's almost like a real service. Well, you can pretty much make it like a real service as well, based on your scenario. Besides that, these are the two toolings that I'm going to use today. So Swaggerhub, for those of you who are familiar with Swagger.io, which is the open source tooling, Swaggerhub has all of the features from the open source tooling itself. So that is CodeGen, there is editor, and then there is Swagger UI. So if you already have Swagger specs, you can pretty much import them on service virtualization tool and directly get started with creating a mock services across, and then adding logic behind your responses. But Swagger Hub is built on top of Swagger.io, so it has all of those features. Plus, in addition to that, it's more like a portal built for teams so that they can design, develop, document, maintain all of the APIs that they have on their end. So in Swagger Hub platform, you can have team built. You can also pretty much go ahead and add standardization or governance around your APIs. You can create domains, which is nothing but reusable components. So if you have scenarios where if there is a certain response which is repeated across 5 APIs, rather than adding it 5 times, you can actually make sure that you add it to a domain file so that in future, if anything changes with that response, whether a parameter name changed or was deprecated, you can just do those changes in a single domain file and propagate those changes across anywhere that API domain is referred. This Swagger Hub also acts like a centralized repository for all of your API services. So you can pretty much have team members added across. You can control the permissions across those team members. It also pretty much provides like a catalog view. You can search or filter through specific things or specific APIs or domains that you're looking into a organization within Swagger Hub platform. Then there is Service V and Word Server. So Service V is pretty much the service building capability is hosted on Service V itself. And then Word Server is where you can go in and share the services that you have built. So if I have 5 team members who are building services currently on Service V, they all can deploy their services on Word Server so that Word Server can centrally host all of these services, rather than giving your users individual IP or domain endpoints. You can just send stores or provides Word Server's endpoint, and that'll be running centralized in a centralized format within your network. Besides that, you can also generate logs centrally. You can also go in and generate audit logs or reports. You can collect transaction logs. You can get activity metrics across the Word Server centrally, and there are no rate limits across on Word Server. So Service V and Word Server work in conjunction. Service V is where you can go in and import your Swagger spec, or if you actually have a live API, you can directly go ahead and start virtualization across the live API. So unlike Swagger Hub, which is mainly focused on REST APIs, Service V actually works with JDBC, SOAP, TCP, and REST API virtualization. So in addition to the Swagger APIs, we can get started in multiple ways. So if you have like a WSDL file, we can work with that. If you have a JDBC database or a query that you would like to virtualize, you can also do that as well, or a TCP or JMS service. Service V is where you can add logic. So all of the requests that are incoming, you can pretty much go ahead and add logic behind each and every response that is being dispatched. across. And then once the service is built, you can then deploy it on the word server. So now moving on to the product. So I'm just going to give you a quick 10-minute overview on Swaggerhub platform, and then we can move a service from here to service virtualization, which is on Ready API platform. So as you can see on the left side, I'm part of 2 organizations. So these are the 2 organizations that I'm part of. Once you're part of an organization, you can go ahead and add team members and manage their permissions across. This is also like a centralized view or centralized repository of all of the APIs that you have. So if currently you and your team members are storing your Swagger specs on GitHub, Atlassian Wiki, or on any centralized platform that you have on your end, rather than storing them there, you can actually have a single or catalog view of all of the APIs. You can also control the permissions across each and every team member. So it's not required that anyone can come in and edit these API specs. You can actually manage the permissions across each and every API that is added across here. Besides that, it also helps with managing the Swagger specs that you have on your end. So if currently searching for an API or discovering an API is a difficulty, whether you're going through like repositories or Atlassian wikis, right? Rather than that, on Swagger platform, you can pretty much just search for a keyword. So there's a keyword tied to whatever specific word that you're looking for. The metadata is getting searched across the Swagger spec, and you can pull up that specific Swagger spec that you would like to go over. Besides that, there are some pre-built filters that you can leverage. So the first one is pretty basic. So if you're using OS 2 or OS 3, you can go ahead and search for the specific spec version that you're working with. We support both. If you have scenarios where you have APIs, now APIs is pretty much the Swagger spec that you're working on. So if I'm building like a library API, I'm getting books, updating authors, creating new books, records across the library is pretty much the API spec that I'm building or the service spec that I'm building. Domain, on the other hand, is something that is native to Swaggerhub itself. And domain is essentially applied for scenarios where if I have 5 APIs which work together, and if there is a schema or model that is repeated across these specs, or if there is a standard 401 or 400 or a 200 response that is repeated, or even a variable that is repeated across all of these specs, I can create a domain file and add all of the reusable components there, and then have them referred across each and every API. So domain helps with consistency. It also helps with managing changes. So in future, if anything changes across these parameters or across the response or the schema or model itself, or the data type changed, or certain property in your schema got deprecated, all of those changes can be managed directly from domain. And once they are added there, it'll be directly propagated to every API wherever that domain is referred. So the type is pretty much a filter which can help you to pull up either the domain files or APIs within the organization. Then there is public. So Swaggerhub platform itself has a SaaS version as well as an on-premise version. So depending on your use case, you can deploy either, as well as you can manage these APIs. So you can either privately share all of the specs that you built here just with the team members within the organization, or you could also make anything public. So if you are comfortable with making your spec public and providing access to your partners, you can also pretty much go ahead and do that. Then there is published and unpublished state. These are essentially, this is nothing but if you have a scenario where you're working with a specific version. For example, if I was creating 1.0 version, I started with it, and then by sprint 5 or sprint 6, I'm actually going to move to another version and continue working on that. And I would like to publish all of the changes that I've done in the previous version so that it goes in non-readable format. So anything that is published goes in read-only format so that no one can go in and edit it. And then you can move to any other version and then continue working or evolving on that further. So that's one of the key benefits here, which is you can essentially publish any API and then move to the next version so that no one else can go in, and unless they have correct permissions, no one can go in and unpublish this further. Besides that, you can manage team members, you can add individual team members, or if you do our LDAP integration, you can go ahead and manage teams based on their groups, or if you can also go ahead and build your own custom team across based on the roles that you have on your end. So that rather than managing permissions across each user, I can manage permissions across the role that they're part of. So if I have a scenario where I have an API architect who is not necessarily going to edit, but will probably require read and comment permissions, then you can go ahead and apply those to a API architect. If there is API dev or a designer team, then I can make sure that they have read, write, and comment permission across. And then consumer could just have a read only permission. And consumer could be anyone, right from the testing team to someone who's building services for virtualization, or it could also be someone from partner um, with the APIs that you partner with, so that they can just see what kind of APIs or services you're building, or what are the required parameters that you need to be shared. Besides that, there is also standardization. So this is another way to drive consistency across the main organization. So if you have a scenario where you would like to create a standardized way of building your specification itself, you can go ahead and do that by just adding specific requirements. So if anyone is adding an API to this organization, they can make sure that there is always a non-empty description string. There's contact information added, or if there is a get, put, post, or any method that you're adding, or any operation that you're adding across, there's always a 2xx response present. Besides that, the model information can also be, so this is nothing but governance around your APIs. So once you have all of this built, you can then manage your Swagger specifications in way easier format. They're easy to discover, have a catalog view across. And then any API spec that you build on your end, you can pretty much go ahead and search it. So for virtualization today, I'll be actually using this Swagger spec, which is a Swagger pet store. And it has these methods that were added directly across. And then in my scenario, I have a GET request that I will be working with. And as you can see, if there is any spec that is added here, and if you have defined a 200 response across here, when you create a dummy service, the responses are imported as well. So whatever edits or whatever service contract you build, when you convert this to a service, a virtualized service and service fee, all of those changes are reflected across. And to get the Swagger spec itself, you can either use the hosted URL in Swagger JSON or YAML format, or even on the Swaggerhub portal, you can download the JSON or YAML file directly from here and get started from there. So these are the options that are there to get started. And then this is Ready API platform. So those of you who are new, it is a desktop application. You can directly download it on Windows, Linux, and Mac and have it available on your end. The platform itself consists of 3 tools. So SOAP and Load are client-based tools. So you're always a client sending out requests to your service and getting a response back. Whereas Service Fee Pro, which is the main focus of today, is the tool which is leveraged essentially for virtualizing services, creating a dummy service directly from Swagger spec or from Waddle, WSDL, and then have your dynamic responses dispatched. And as mentioned previously, you can leverage it either for getting in parallel with your dev team so that your service, which is still under development, you can have a mock run against it so that you can get started early on with your functional test, unit test, or even have your UI teams get started earlier so that you have fast release to the market, or by recording any live API. That's the other scenario where if you want to cut down the dependencies, you can pretty much go ahead and record any live API and go from there. So to get started with service virtualization, for today's session, we'll be just covering getting started with a definition or descriptor which is with the Swagger spec. But you can also pretty much record any live traffic and create a dummy service from there. So that is an option. Or you can also manually input, like for example, if you have a scenario where you have multiple methods that you work with, where you get information, update information, or create information, and you have the resource paths that you want to get started with. So you can pretty much get started with that as well. But for today's session, I'll be starting with this pet store Swagger spec that we have imported. And as you can see, I'm just pasting the link to the Swagger spec itself. And then there will be a couple of steps that'll happen in the creation process. You can add this to an existing project, or you can create a new one. And then you can directly have your service run across. You can ignore this pop-up for now, and we'll go back to it again. But just to give you an overview on the service, this is the service that we have built currently. This service is running on localhost 8088. So right now it's running on my machine locally on localhost 8088. Now the incoming are basically the incoming requests. So anytime I send a request to localhost 8088, it can be categorized with this resource path and method, or with a post method and then the specific resource path, or it could be one of this. So depending on the request that is incoming, you can classify which request actually came in based on the request and the method. So incoming is nothing but the descriptor for the request that is incoming to the service. And then outgoing is essentially just the response that was dispatched. So anytime you have a scenario where you have a pre-built 200 response defined in your Swagger spec, you can pretty much go ahead and have that imported directly from the service contract itself. Besides that, you can also go in and create different HTTP status codes. So if there's a requirement where you would like to go ahead and create a 400 HTTP status code, you can go ahead and do that across here, or whichever HTTP status code that you would like to work with. Too many requests if you're adding some kind of limit, or even 201 for a post request. So you can create different HTTP status codes across here. You can also delete any of the responses that you have built. But outgoing essentially stands for the responses that are dispatched based on the incoming request. And then there is dispatch style. Dispatch style is nothing but this adding logic behind your request. So anytime you have a request incoming, and if I have multiple responses that I might dispatch, for example, if I have like a 405 method and then other one is something else. So in this scenario, it's again 405 in my pet store definition, but let's say I have a 200, and then if I have a 404, I can, or 400, I can then decide when to dispatch a bad request and when to dispatch a 200 OK response. So you can pretty much go ahead and decide based on a certain logic when to dispatch a response. Now to add logic, there are different dispatch styles. Sequence and random has no logic here, but then there is query match. So the query match is where essentially you can go in and add logic behind your responses. So query match can be leveraged where dispatch style query match can be leveraged where if I have a post request incoming, and if I send like a JSON payload and I would like to dispatch based on the value that I send in payload, if I would like to dispatch a specific response, I can go ahead and add a query match. If you have XML incoming, you can add XPath dispatch. If you have parameters, like pet ID is a parameter essentially for resource path parameter, or a path parameter that is added across. So you can go in and add rules here. So I can select path here, and then you can select a pet ID. And then you can decide whether it's equal to, or if there is a pattern that should exist in pet IDs, it should start with like 2 alphabets and then followed by a special character and then 3-digit numerical values. Then you can go ahead and add a regular expression pattern based on which response you would like to dispatch. You can then select the specific response you're dispatching based on your requirement. You can also create like a bad response or a error response for a default response as well. So these are some expected strategies that you can leverage for adding logic. Script is for any scenario where you're customizing the values further. So if you're adding like, or if you're adding like multiple conditions based on which, if you have an if and else condition where I have 3 200 OKs, and if A is true, then I would like to give the 200 OK for response 1. Else, if any other condition is true, I would like to dispatch another 200 OK. Or if there are multiple schemas that are tied to your response, you can then also go ahead and add logic. We always provide, with our script, there are also always dummy scripts that are provided that you can reference. Besides that, we also have code completion across the code, or if you are actually importing your own Java customized jar to work with, you can go ahead and pretty much reference those across. So for example, if I have a scenario where you add mock request dot, you can pretty much go in and leverage all of the IntelliSense or the implementation class methods across the object or instance that you have added here. Besides that, if you added your own custom jar in Ready API installation bin directory, you can restart Ready API and start referencing the jar methods directly. So since this is a Java product, we can directly work with Java jars or Groovy classes out of the box. So for this, the pop-up that we saw earlier, as you can see, we are agnostic towards the client. So if I send a request from this pop-up here, it's just a JavaFX client from browser. If I send a request from here, we can pretty much work with any client as long as it sends a valid REST request or a valid SOAP request or a JMS request. So anytime you have a scenario where your incoming request is valid, it does not matter that you have to use only SmartBear tools for sending out requests or use just SoapUI, LoadUI, or open source SoapUI. You can pretty much use any tooling on your end, rest assured, Pets or Postman, or even a code-based client and send out requests across. So depending on your use case, you can go ahead and leverage any type of client here. Besides that, you can also dynamically send values here. So if I have a scenario where I want to send dynamically a pet ID in here, you can directly send that as well. So I'm just going to send. So as you can see, I have an incoming pet ID that I actually send in the request, and I can now dynamically send it back in my response. So now if I send a request to this dummy service, by default, it always hosts a service on HTTP. But if you have requirements for HTTPS, you can enable that with preferences. So on the Ready API platform, if you go on preferences in SSL settings, this is where you can enable virtual service SSL and add your key store password and enable the service so that it runs on HTTPS. But for today's scenario, I'm actually just going to run a dummy request. Right. So if I now send a request here, you can see that when I send 3 here, it's actually dispatching 3 back in my response. If I send this a 4, it'll dynamically pick up the parameter. So anytime you would like to refer values that you send within the request in your response, you could just add a dollar curly braces and refer it across. Besides that, the service is currently running on my machine, so it's taking the behavior of my machine. But if you have scenarios where you would like to emulate the service as much as possible with the real-time service, then you can go ahead and add response delay or latency or min or max thread. So any limitations across, you can go ahead and add those here so that it can emulate the real-time service as much as possible. Besides that, there's also transaction log. The transaction log is pretty helpful for scenarios where if you're using SoapUI Pro or open source SoapUI tooling, you can pretty much refer the raw request that was sent and the raw response that was received. But on the server side, this can be helpful for scenarios where currently, if you have a service which is, or request which is sent from a code-based client, and if you are dispatching responses based on those, and if you'd like to just refer the request that actually came in, whether it was in a proper format or not, you can actually refer it here directly rather than running Wireshark or Fiddler. So that is one of the key advantages for having transaction log across, where you can pretty much refer the request that came in and refer the payload that came in, and also refer the response that was dispatched across. Besides that, every service that you host here, you can pretty much go ahead and add authorization that is expected. So if you have a scenario where you are expecting basic auth, you can enable it so that unless and until this authorization header is present in your incoming request and your header starts with basic, it won't actually go in and process your incoming request at all. So it won't actually spend time even processing or trying to process the request, and it'll directly send a 401 back. So you don't have to go in and add like individual across each and every method, add validators to validate the authentication. All of this can be taken care of directly from the auth tab itself. So you can host a service which expects any of these headers or any custom header that is required for your service to run or process the request. Then there's data sources. As you can see, this current response that I have on my end, it pretty much has like static values added across. The only dynamic value that I have is based on the incoming request. I'm just sending or dispatching a dynamic pet store ID across. So if that is the scenario where you would like to go in and dynamically add a random name, or if there is a requirement where you would like to generate. So for IDs, I can pretty much go ahead and create a dynamic response by just adding this across. But if I have scenarios where I would like to add a random name across for the pet, as well as if I have a random dynamic value for status or any of these parameter values which are dynamic, I can go ahead and add a data source for that. If you have a scenario where you have a backend data set, you can pretty much get this pet store ID and query your backend data set based on the request that is incoming. So for example, if I send pet ID 1 and if I have a backend database table which has name or pet information specific to the ID, it's tied to the ID itself, I can go ahead and query it and dispatch a response back, which basically contains all of the values dynamically created across. So you'll have like a basic template, which is nothing but the schema or the JSON reference or XML reference or a template created here. And all the values will be dynamic based on the incoming request that you create. So for that purpose, we have something called as data sources. Data sources helps you to dynamically change values in your responses. And then in my scenario, since I just have a name parameter, which is getting created dynamically, if you have an Excel file, we also have pre-built scripts which can help you to query an Excel file and get specific row back from your Excel. As well as if you have a database, you can pretty much query the backend data set. Since this is a Java platform, you can pretty much work with any database as long as there is a JDBC connector associated to it. So right from Cassandra, MongoDB, to MySQL, MS SQL. So we work with all of these data sets. And then there is data generator. This can be leveraged for scenarios where you don't actually have real-time data available right now. Could be because your service is still under development, or it could also be scenarios where you're running like a bank or a healthcare application where you don't have access to the real-time service or real-time data. So for that purpose, what you can do in here is you can pretty much go ahead and add dummy data set from this data generator. So there are different types of data set that we have here. So right from cities to Boolean values. So this covers most of the data sets that are available. So you can pretty much go in and generate those across. We also support inline scripting here. So if you have a scenario where I'm actually gonna pull up a value here. So if you have a Java UUID or a date time that you would like to generate for SOAP UI, you can go ahead and pretty much just dynamically cache that up as well. So if there is like a dynamic data value or dynamic date time that you're generating across, you can pretty much just copy the inline script here. And we actually generate inline scripts, not just for like a GUID, but also for scenarios where you generate a date or a random number or an integer number, real-time number. We have inline scripts for those as well. You can pretty much go ahead and paste those as well directly so that it just generates dynamic values across. For this session, I'm actually just going to add a dummy name generator. And you can also be specific here with as to which gender you're generating against. I'm just generating the first name across. And then in my response itself, I just link it to the data source. And then under the name tag here, I'm literally going to use right-click get data functionality, which just helps you to pull up the value that you're looking for. All right, so this is the dynamic reference that is created now. And now if I reach out to this service, earlier it was giving all the static responses back. So it was giving string as the response values, and also there was no Java UUID. And the ID was the only dynamic parameter. So based on the value that I sent here, if I sent 5, it was just sending a 5 back in the response. But now with the data source generator, it will directly send dynamic values across. So if I run this, and if I run it multiple times, you can see that now we have dynamic values coming back in our response. So this can be leveraged to create dynamic values, and then you can refer them in some other and store them in a data set and then go from there. Or you could also pretty much go in and query a backend data set, and based on that request value that you've created, you can get specific response back, which is specific to the data set that you're trying to display here in the response. So you can pretty much customize all of this flow here. Besides that, once the service is built, you can also start routing and record. So we have a functionality where if the service is built from Swagger spec when the actual service was not live, you can also create conditions here where based on a certain condition, work with the dummy mock, or else, so you can set up a conditional flow here where I can route it to the actual live API based on a condition. So if condition A is true, then use the mock response, else use the live response. So going forward on the service, you can also enable routing across. You can just enable routing across non-virtualized services. So for example, if there's a new delete a pet method added across, you can then just route that specific method. Or you can also route it and record it across. So even when the service is built, you can enable routing, recording across depending on your use case. You can also search here. So based on your requirement, you can go in and search just for a get method across. So if you have a scenario where you have 20 methods associated to your service, and currently it's getting difficult to manage them, for usability, you can pretty much search across incoming routing options, dispatch styles, or outgoing. Once the service is live, you can, as you can see, you can pretty much reach out from a local client because it's running locally across on my machine. But if you have a scenario where you would like to send a request from multiple QA machines, or if you have a CI/CD pipeline from where you are sending a request and you're running multiple agents or test runners in parallel. So for that purpose, we have something called as Word Server. And Word Server is nothing but like a headless installation that you can pretty much install anywhere on your network. And once it's installed, it's available in Windows, Linux, and Mac. We also have a Docker image for the Word Server. And once it's installed, you can pretty much get connected to it with the host and the port where the Word Server is running. So it runs on HTTPS endpoints, so the traffic is encrypted, and then you can just add the IP and the port for the Word Server. And then in order to deploy this service onto the Word Server, all you need to do is literally drag and drop. And once it's on Word Server, you get an actual endpoint that now you can share it across all of the consumers who are actually going to refer to the service that you have built. You can just go in and share the HTTP host name and then the port across, and that'll just dispatch responses from there rather than running it from locally. And as mentioned previously, it also has transaction log capability where I can collect logs across each and every service that is deployed here. You can get activity metrics across. So if there are 5 users who are leveraging Word Server, I can see who started, stopped, deployed any service across. You can also collect metrics. Now the Word Server itself also has a web UI version. So if you have a scenario where this service, which is running locally currently, you can definitely access the word server from here. But if you're someone like an admin who's not necessarily going to download Ready API platform or install Service V, but all you're essentially doing is collecting logs, generating reports across for amount of traffic that your service got, or even generating audit logs, you can then refer the word server on the URL itself. So I can just put the host name for wherever the word server runs, and then the port number, and then / with word server, you can add like the web UI client. And this is where you can pretty much edit the port. You can tag services that run together. You can generate the audit log and see as to which user has logged in or which user has deployed services across here. You can also generate reports. You can get traffic reported as well. You can generate hard log files. So if you want to refer the raw request, raw response for each and every service request that came in, you can pretty much refer that across here. But word server essentially helps you with managing the traffic or managing the services that are deployed on the word server. And this can be essentially very helpful if you're someone who's an admin who's just going to manage these services or run them on CLI. But that was essentially an introduction to Swaggerhub and word server and Service V, where you can build services and then deploy on word server. And this is how you can virtualize your service in a couple of clicks with the Swagger spec. Any questions?
Yeah, if you have questions at all, feel free to enter those into the Q&A box. I think we had one question come through from chat.
Mm-hmm. So there's a question asked that, can we install Swaggerhub in local and start using all of these functionalities? There is an on-premise version for Swaggerhub, which you can, but you'll need to contact SmartBear. But if you're using the online version, which is swaggerhub.com, there is also free user account that you can pretty much get started with.
All right. I'm going to run a quick poll. If anyone's interested in learning more, we'd be happy to set up a quick demo to walk you through how exactly Swaggerhub and Service V Pro could work for your team. So feel free to sign up, and we'd be more than happy to reach out with some more information. Yeah, and while that's open, feel free to put in any questions that you might have, and we're happy to take the time to answer those.
So there's a question asked, what are the languages to create scripts supported? So there are, across the Ready API platform, there are 3 languages that you can directly work with. So there is Groovy, there's Rhino JavaScript, which is a very older version of JavaScript. And then you can pretty much add Java. Like this directly works with Java as well. If you have your own custom Java jars, you can also import those and get started from there as well.
There's a question about the recording of the session. So the session is recorded. We will send that out either tomorrow or Monday.
So there's a question about how long is the trial version. So the trial version is for 15 days, but if you communicate with the account manager for your POC, they can extend it. There's a question asked about, is Python supported for the script? So currently not. It only supports Groovy, JavaScript, and Java code directly. There's a question asked about how service virtualization helps teams deploy microservices in production independently of the services on which they depend. So if you have scenarios where if you're updating a specific service, and if that service is going to go down, you can create a mirror service for those scenarios, either for dependencies, or you can also record a live API. Or if you have scenarios where you want to add this service or the service that we've created as a proxy, so that any request that comes in to localhost 8088 or to the word server, I can route it to the actual service endpoint, or I can use a dummy mock. So if the new function or new feature is not yet built in the live mock, then I will create the mock version for it and then just route everything else to the actual real-time service. So if there's a new version coming out, and if there's a Swagger spec created for that service itself, or just for that microservice, you can mock it out, and then all of the new functionality requests can come in here anytime when they're load testing or doing like a functional testing, and all of your live service requests can go to the actual service. Like all of the old functionality can be actually pointed to the production environment itself. Then there's a question asked that once you deployed real services, can the virtual service redirect calls to the real services? Yes. You can route it to the live API. So this is the routing feature that is highlighted, helps you to route it. You can also do conditional routing across. Is it possible to manage request headers with Service Suite? Yes, you can manage request headers as well. So you can either add them dynamically with a script, or if there is like a specific response header that's coming in, or if you're based on a condition, if you're getting like a request. So I can just get mock request object here, and then in the dot, I can get the request headers. So you can get directly the request headers and refer them here. If you're using like any of those pre-built headers and you don't want to process until unless a certain header is present, then you can just add that header here. And if that header is not present, you can send a photo and back. So that is another way of managing the headers. Can JSON-based key value data source be set up to return dynamic responses based on specified inputs? Yes, we can work with that as well. So you can set it up with file. Then there is, how long is a trial version? I think I responded to that to like 15 days by default, but you can extend it.
All right. I think there might be a couple more in the chat.
Yeah, I'm going to check chat now. Okay. Is there any Swagger tool to convert JSON to Swagger documentation YAML in organized way? Yes. So there is inspector tooling, which is a free tool from SmartBear, where so if you have a bunch of API calls that are already live, for example, this is a Google Maps API call, which I'm sending a request to. Let me update the my security key here. All right, so if I do a send request here for a post request, and then if there is another get request, which I'm working with, or whatever calls you have with your API, you can go ahead. So this is pretty much similar to Postman, where it has like a method. You can select the method, then you have all of the endpoints that are common with maps.googleapis.com, and all of the methods that are related to that. I can directly add them here, and I can add parameters here and then generate responses. And once they are done, once that is done, I can select all of these request URLs that I sent, and I can directly create a specification here. So once that is built, so if I had like 20 calls that I'm doing to my API, and once those are added here, if you have a WADL file, you can directly get started by just adding the WADL itself, and then you can select any. And then if I click import API, it builds a skeleton spec directly out of the box for me. And then I can go in and add more information, like if anything is marked as required to true, like address is something that is required. So I'm going to set that as true. So you can also go in and add description. You can add example. If you added an example in the query itself, when you made that, it'll get added directly. So, but you can customize this further by adding your own custom description, adding your own metadata associated with the usage. There's another question asked about And then once you have a spec here, you can also convert that to a YAML. So that's how you can convert it to YAML as well. If we are using hosted Swaggerhub, our word server and service fee available as part of the hosted solution. So service fee and word server are desktop applications. You can directly download them onto any machine. Generally, what we recommend is service fee should be leveraged only by users who are actually virtualizing, and then all of the consumers can just have the endpoint from the word server and then have access to it. So they don't, like, if I'm someone like a tester or UI builder, I don't really need word server or Swaggerhub or even service fee. So based on whoever is going to use what, you can download it. Inspector is a SaaS tool. You can directly download it anywhere. So like you don't need to install Inspector. It's pretty much, if you just search for Inspector SmartBear or Inspector Swaggerhub, it should be coming up first. There's one more Q&A. We generate OS spec from code. Can this be automatically pushed into Swaggerhub for read-only distribution for dev tests? Yes. On scenarios where you are Swaggerhub itself has a backend registry of APIs that you can go in and manage across. So if I have scenarios where I'm updating or posting across APIs, I can directly just post them here in read-only format so that they can be available across any from the backend itself. So what I can do is on CI/CD pipeline, if I had a successful code build, you can then go in, generate Swagger spec, do a webhook integration, and post it on the Swaggerhub using the Swaggerhub backend call. So that way you don't have to go in and do those or import those manually or actually copy pasting Swagger spec directly. There's a question asked about what is Ready API. So Ready API is a desktop application. It's essentially just API focused tool where SoapUI Pro does functional testing. This is where you can build functional tests and go from there. Then there is load test, which is essentially doing performance tests across your APIs. Soap and load are pretty much client-based tools, whereas service fee is where you create a service and host a dummy services across for mocking or virtualization scenario, and then you can dispatch dynamic responses back based on your incoming requests. Yeah. I think that is, so we answered what is Ready API as well. Is there anything on the chat left?
I don't believe so.
Perfect.
All right. So thank you again, everyone, for taking the time to join us for this session. I hope everyone got a good sense of what exactly your team could get out of service virtualization and how Swaggerhub and Service Fee Pro could help in that process. So thank you again, and have a wonderful day. Take care.